So for this problem, what we have to do is find the velocity at the bottom of the inclined plane. So the formula for velocity is v squared equals 2 times the, 2 represents the mass, in this case, mass times the gravity with the sine of theta and the displacement of x, which in this case is the 3 meters. So what we have to do is find out what that v is, and if we plug in the numbers, v squared equals 2 times 10, sine of 30 is 0.5 times 3, which is that displacement, equals v squared equals 30. The square root of that is v equals 5.5 meters per second squared at the bottom of the inclined plane without friction. Now for b, we have to find it if the friction is 0.3. What will the velocity be at the bottom of the plane? So we first have to find what the acceleration of x prime is. And how we can do that, the formula for that is the gravity times the sine of theta minus that the null friction times gravity as cosine of theta. And that's going to give us the ax prime. So once we plug in the numbers, we have ax prime equals 10 times 0.5 minus 0.3, which is the value, times 10 times cosine is 0.87. So once we do that, it's 5 minus 2.6, which equals 2.4, and that is our ax prime. Now, to find the velocity is going to be 2 times a with the displacement of x, and this is the ax prime that we're talking about. So we plug in our values because we now have found it. So we have 2, which is that mass, times the acceleration, which is 2.4, and times 3 meters. And we have to find the square root of that. And we find out by solving it that it gives us 3.8 meters per second using that friction force. So that's the difference.